The paper of the day is Everything You Always Wanted to Know About Compiled and Vectorized Queries But Were Afraid to Ask. It's a 2018 paper. The query engines of most modern database systems are either based on vectorization or data-centric code generation. These two state-of-the-art query processing paradigms are fundamentally different in terms of system structure and query execution code. Both paradigms were used to build fast systems. However, until today, it is not clear which paradigm yields faster query execution, as many implementation-specific choices obstructed direct comparison of architectures. This paper experimentally compared the two models by implementing both within the same test system. This allows to use for both models the same query processing algorithms, the same data structure, and the same parallelization framework to ultimately create an apples-to-apples comparison. Paper finds that both are efficient but have different strengths and weaknesses. Vectorization is better at hiding cache miss latencies, whereas data-centric compilation requires fewer CPU instructions, which benefits cache-resident workloads. Paper uses DPCH and SSP, that is star schema benchmark, for evaluation. There are 5 key contributions. The performance of vectorized and data-centric compiled query execution is quite similar in OLAP workloads. Computation. Data-centric compiled code is better at computationally intensive queries, as it is able to keep data in registers and thus needs to execute fewer instructions. Parallel data access. Vectorized execution is slightly better in generating code parallel cache misses, and thus has some advantage in memory-bound queries that access large hash tables for aggregation or join. SIMD has lately been one of the prime mechanisms employed by hardware architects to increase CPU performance. In theory, vectorized query execution is in a better position to profit from that trend. In practice, we find that benefits are small, as most operations are dominated by memory access cost. Fourth, parallelization. We find that with Morsel-driven parallelism, both vectorized and compilation-based engines can scale very well on multi-core CPUs. Hardware platforms. They performed all experiments on Intel Skylake, Intel Knights Landing, and AMD Ryzen. The effects listed occur on all of the machines, and neither vectorization nor data-centric compilation dominates on any hardware platform. Now let's talk PS score. Overall, this paper is a decent read with some bumpy parts in experiment and evaluation sections, so it gets 7 out of 10 on readability. With 14 pages long, it scores 8 out of 10 on length. The description of the approach is decent, so that makes it 7 out of 10. Industry value and learning meter is decent, nothing special, so it gets 6 out of 10 on each. Overall PS score is 7 out of 10.